In this lesson, we will talk about object-oriented programming, specifically class design and class relationships, right? So there are two concepts that I want to talk about. The first one is abstraction. Abstraction refers to separating implementation and how something is used. We know that abstraction is already provided by methods, right? Methods separate how something is implemented, which is the body of the method, from how they're used, which is a signature that we provide other people to use our methods, right? Now, class abstraction separates implementation of the class from how the class is used, right? A class's contract with the outside world is the set of signatures of public methods and public variables that it provides, right? The details of the implementation of the method and how what private data variables it might be used is hidden from the user. This is called class encapsulation, right? A class that is implemented in this way is called an abstract data type. An abstract data type is a well-designed data type, right? So if you were taking previous classes and before object-oriented programming, you were basically writing programs using methods, right? And but in object-oriented thinking, we couple data and methods into objects, right? And create abstract data types, right? Later on in other lessons, we will get to implementing interesting data structures such as stacks and queues. And there, you might decide to implement it inside with arrays or with linked lists or whatever, but that is not something that will be exposed to the user who is using your new data type. All right, with that, we move on to class relationships, a very important concept in object-oriented programming. Now, there are four types of relationships that we can talk about. The first one is association, which is a general binary relationship that connects two different object types. There's aggregation, which represents ownership of one object owning another object, and we typically use the term has to describe that. Composition, which is also an ownership, but it's an exclusive ownership where an owning object exclusively owns that other object. There's inheritance, which we will cover in future lessons, right? So let's talk about them one by one. So association. Association describes any relationship between two classes, an activity between two classes. For example, if you take three objects, a teacher, course, and student, a teacher teaches courses, student takes courses, right? Student could be enrolled in a course. So an association in UML is represented by a solid line, right? Optionally, we can use a verb or label to describe the relationship. In this case, teacher teaches course, or a course, or a student takes course, right? Or a course is taken by a student. There is a number next to both ends of the relationship that represents the cardinality or the multiplicity of how many objects are involved in this relationship, right? So this can be a number. It can be an asterisk, represent an arbitrary, an unlimited number of objects, or it can be a range like 0 to 3 or 10 to 50, right? So let's talk about this particular example. In the above example, one teacher can teach 0 to 3 courses. The teacher may teach nothing that quarter, for example, but at max they can teach 3 courses. A course must have 10 students to be viable, but can have no more than 50 students, right? Now let's talk about how this is represented in code. So in the above example, a teacher can have multiple courses, so we represent that with an array, right? Similarly, a course can have only one teacher teaching it, right? And a course can have multiple students on the other side, right? Now, lastly, a student can be enrolled in multiple courses, which is the relationship here, right? All right. Now, let's move on to the next type of relationship, which is aggregation and composition, right? They go together. And aggregation is a special form of an association that represents an ownership in action, right? So it models what we call a has-a relationship. Something has something else, right? So there is an aggregating object that owns the aggregated object. So those are the two objects, right? Now, an object can be owned by other aggregating objects. An aggregated object can be owned by multiple aggregating objects, right? So let's take an example. So a student and an address, right? A student has an address. It's represented like this. Now we'll talk about the notation in a little bit, right? So this, again, you have the cardinality. Now it is also possible for other students to live at that address. So 1 to 3 students might own that address. So multiple students could possibly own that address, right? Now, suppose it was an exclusive relationship where the aggregating object exclusively owned that object, or that object only belonged to one aggregating object. So now let's take an example. An example here is a name. A name only belongs to one student, right? So there is that one-to-one relationship. Now we have the multiplicities as before. Now there is a diamond here. The diamond is next to the aggregating object, the one that owns the other thing, right? So it is a solid diamond for an exclusive ownership, which is called a composition. And then there is a hollow diamond for the aggregation, general aggregation relationship, right? Again, we can look at what this might look like in actual code, and it is fairly straightforward. So a student has a name and a student has an address, right? So those are kept as variables, right? And you don't really represent anything in the on the other side, because it is really the aggregating party that is interested in this relationships, right? Okay. Now, aggregation can also exist with objects of the same type. So here's an example. A person can have a boss relationship with another person, right? So a person can relate to themselves. So here is the UML that would represent that, right? The relationship is going back onto the same. Now, it is not an exclusive relationship, right? A boss could have multiple reports and such, right? There's also a possibility that you might have multiple bosses. That's also possible. So it's an exercise I'm leaving to you of how to represent this in Java. We'll actually get some exercises in this in the programming assignments that you might do. All right. That is the lesson on class design and also class relationships.